This time, we will discuss bisection method. Bisection method is another method in finding the roots of a nonlinear equation system. This method falls under the category of bracketing method. This method will make the function of x equal to 0, where the value of x lies somewhere in the interval a and b. This is just simply bringing the two endpoints a and b closer and closer together until we obtain a smaller width of the interval of a and b that brackets to a zero root, which is r. If we are going to plot the function, let's say this is the y-axis and this is the x-axis, and this is the function of x, which is also equal to y, and the root of the function is at the point where it crosses the x-axis, and that is r. In this method, bisection method, the root is between two endpoints. So here, we let this one as our point or our endpoint A, and here, this is also our endpoint B. The coordinate of the function at this point is A, function of A, and here also the coordinate of the function at that point is also B, function of B. The process of this method is to have the interval of A and B, or finding the midpoint by bisecting the interval of these two endpoints A and B, and that midpoint is point C. The coordinate of the function at point C is C, function of C, until the interval of these two endpoints A and B becomes smaller and smaller to reach R, which is the root of the equation. The analysis of the interval half that brackets the root R, we will use the following assumption. First, if the function of A and the function of C have an opposite signs, the root of the function lies in an interval between A and C. Second, if the function of C and if the function of B have an opposite signs, the root lies in an interval between C and B. The last one is, if the function of C is equal to 0, then the root R is equal to C. After the analysis or after the process, we will relabel our new value of A and B, then repeat continuously the iteration process until the interval or the distance across the interval containing the root R may become smaller and smaller, or the value might be equal to 0. We will use the following procedures in the analysis of bisection method. So these are the procedures. First, start with an initial guess of two endpoint values AO and BO, but you have to make it sure that BO is greater than AO. Then, second, compute the midpoint CK by adding AK and BK, then divide it by 2. Third, compute the function of AK, function of CK, and function of BK. Then, Analyze the values and review the 3 possible cases that might arise. So these are the 3 possible cases. This one. Then after the analysis, you have to relabel your new AO and BO. Then repeat the process until you obtain a smaller interval that brackets to a 0 root. Okay, thank you for your time in listening and watching this video, and I hope you understand, and God bless.